Hi students, this is Alex here. In this problem, they were given f of z, which is u plus iv, and is a regular function of z, and we have to prove this expression. Let's start from f of z. F of z is u plus iv, and mod f of z will become root of u square plus v square. And this can be written as u square plus v square whole power 1 by 2. Now coming to left hand side, we have del square mod f of z power p, that is equal to del square operator is dou square by dou x square plus dou square by dou y square of mod f of z power p, which is u square plus v square power half and power p, so total power p by 2. Now let's take this as a two terms. One is d square by dx square of u square plus v square whole power p by 2 plus dou square by dou y square of u square plus v square whole power p by 2. Further, this second differentiation we have to do step by step. So we split dou square by dou x square as dou by dou x of u square plus v square whole power p by 2. In the same way, this is dou by dou y of u square plus v square whole power p by 2. Now, coming to the first part, we are going to differentiate this partially with respect to x. So, outside we have dou by dou x, open a bracket. This differentiation is p by 2 u square plus v square whole power p by 2 minus 1. Then derivative using chain rule, u square is 2u and u derivative is ux, and this is 2v and v derivative is vx. Now second part is plus dou by dou y of p by 2. We can copy the same term because the terms are similar. Only thing is, instead of partial derivative with respect to x, we have to write y. So it is 2u uy plus 2v vy. Now we find 2 is common here and here. When it is taken out here, that can be cancelled with this 2. So the first term is dou by dou x of p into u square plus v square whole power p by 2 minus 1. And this is ux plus vx, and plus dou by dou y of p into u square plus v square p by 2 minus 1 and uy plus vy. Now as a next step, we are going to do product rule for this entire term when we do partial derivative with respect to x. So when we start the differentiation, the first term differentiation is p is a constant. Now p by 2 minus 1 into u square plus v square power p by 2 minus 1 is minus 2. Then by chain rule, u square plus v square we have to differentiate, which is 2u ux plus 2v vx. And the second term should be written as it is u ux plus v vx plus first term p into u square plus v square power p by 2 minus 1 is written as it is, and this differentiation once again for each term I have to use product rule. So first term differentiation is ux, but again into ux, so I directly write ux square plus first term we keep as it is, second term differentiation uxx. In the same way it is vx square plus v into vxx. Then coming to the next part, this is entirely partial derivative with respect to y. So since the terms are similar to the first one, we can just copy the terms, but instead of with respect to x, we have to write with respect to y. So we can copy just everything, p into b by 2 minus 1 into u square plus b square power p by 2 minus 2, and this is 2 uy now, because we are doing with respect to y, 2v vy, and again uy plus v vy, and plus second set of terms p into u square plus v square power p by 2 minus 1, then uy square plus uyy plus vy whole square plus vvyy. So we just copied and we quickly completed the differentiation. Now we have to make a grouping. This first set of terms we can group with the third set of terms because many things are common. So p into p by 2 minus 1 into u square plus v square power p by 2 minus 2. Here, after taking 2 common from this, these two terms will be similar. So we can take 2 common and write ux plus vx whole square. So same thing happens here, but we can take the terms common, after that open bracket. So here the rest of the terms will be uy plus vvy whole square. So we have taken the common terms out from the first and the third set of terms. In the same way, plus from second and last, p into u square plus v square power p by 2 minus 1, we can write the rest of the terms. But again, when we combine here itself, from these two terms, we can group the common terms. Like first ux square I have written, then vx square, then uy square plus vy square. We notice from this and from this we can take u common. So when we take u common, it is uxx plus uyy. In the same way, from these terms we can take v common. After taking v common, we get vxx plus vyy. So close the bracket and close the entire bracket. And at this point, we are going to use CR equations. So using, what are the CR equations? That is ux equal to vy and uy equal to minus vx. This we are going to use it, and at the same time Laplace equation. So using Laplace equation, which is uxx plus vxx equal to, uyy equal to 0 and vxx plus vyy equal to 0. So this part and this part will become 0, and CR equation we are going to substitute here, 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 here. Wherever with respect to y is there, we are going to change it with respect to x. So once again, coming from the beginning, p into p by 2 minus 1 into u square plus v square, and there is a 2 open bracket ux plus vx whole square plus u minus vx plus v, and vy is using CR equation ux. So we replaced everything, close the bracket, and again the next set of terms p into u square plus v square power, actually there is a power here, p by 2 minus 2, and here it is p by 2 minus 1. Here ux square plus vx square and uy is minus vx square and vy is ux square and plus u into 0 using Laplace equation plus v into 0. Now we are going to expand this using a minus b whole square formula, and this is a plus b whole square formula. Now let's continue here. So this is p into p by 2 minus 1 into u square plus v square whole power p by 2 minus 2 into 2. Expanding this, we get u square ux square plus 2u ux v vx plus v square vx square plus this expansion will be v square ux square minus 2u vx plus vux, sorry, into, I have written it in a different order, vux, and last term is u square vx square. Then plus p into u square plus v square power p by 2 minus 1. These two terms we can combine it as 2 times of ux square, and when I square it, this will become positive, so this will become 2 times of vx square. Now we can cancel ux vvx 2 times with minus 2 times of ux vvx. Just a product is in a different order, but we can cancel. Now p into p by 2 minus 1, and this is u square plus v square power p by 2 minus 2 into 2. From here we can take ux square common. So this will be ux square, when it is taken common we get u square plus v square. Again from these two terms, when I take vx square common, the remaining will be u square plus v square. And the last term we can take 2 common, so 2p into u square plus v square whole power p by 2 minus 1 into ux square plus vx square. Now from this u square plus v square is taken common, so from the outside term we have p into p by 2 minus 1 u square plus v square power p by 2 minus 2, and there is a 2 that can be written here, and here when I take u square plus v square common, it can be written outside like this. After that we have ux square plus vx square, and here the second set of terms 2p into u square plus v square power p by 2 minus 1, then ux square plus vx square. Now when I combine these terms, this is power 1, so we have to add these power, p by 2 minus 2 plus 1 is p by 2 minus 1. So let's write that 2p into p by 2 minus 1, and now it is u square plus v square power p by 2 minus 1 and u x square plus v x square plus 2p into u square plus v square p by 2 minus 1 ux square plus px square. Now we shall take the common terms in both the terms. 2p is common, then u square plus v square power p by 2 minus 1 is common, and ux square plus vx square is common. After taking common, the remaining term is just this p by 2 minus 1, and here nothing is remaining, 1 is remaining. So p by 2 minus 1 plus 1. So we can cancel this, and now this is, we can cancel this also because it's a product, that is 2 and 1 by 2. So we can multiply this p and p square. Here we take LCM, u square plus v square whole power p minus 2 by 2, and this is ux square plus vx square. Now coming to this is p square, and this is nothing but f of z modulus is root of u square plus v square. So leaving this power, we can write only p minus 2, because this entire thing u square plus v square along with this power half, let's check it in the first step, is mod f of z. So only in the power we have p minus 2. So we can replace the entire term as mod f of z power p minus 2. And this is f dash of z with modulus, because we have square. So we don't have root. So this can be written as mod f of z whole square, because modulus means we have root of real part square plus imaginary part square, but we don't have square root. So mod f dash of z whole square. I just copy the question here just to verify. So we started from LHS and check whether RHS we have p square, there is a p square, mod f of z power p minus 2, mod f of z power p minus 2, and mod f dash of z power 2. So we got it. So we took LHS and we got the RHS. So hence proved.